Okay, Assalamualaikum brothers and sisters. So, today I'm going to show you the experiment about half-wave rectifier using the silicon diode. Okay, so a silicon diode, okay, I'm not sure whether you can see this grey stripe line. That means that is the N type, which is the negative terminal of your diode, okay. And then if you look at the half-wave circuit in your manual, it uses a 2.2 kilo ohm resistor. So this is the 2.2 kilo ohm resistor, okay. So I'm going to construct the half-wave rectifier circuit. So this is my breadboard, okay. So as I always mention to you, make sure the letters are at the top, okay. So if you look at the circuit here, so you have node A and node B. So your diode must be connected between node A and node B, and the grey stripe must be pointing towards node B, okay, the negative terminal. So that's what I'm going to do. Okay, so this is my node A and B, right? And my 2.2 is connected between node B. So same row, and this will be my ground, okay? Okay, so for my ground, I have this guy. I'm going to use one jumper, and so the output is measured between node B, and then the input is the function generator. So I'm going to show you later the function generator, which is going to produce the sine wave, alright. And then the input is given at node A here, okay, and then the input signal must be connected to ground as well. So this is my ground, okay. So you can see my ground at the same node, then node A and node B, right? Okay, and then I'm going to put the oscilloscope to display the output at the output side. I'm also going to use the oscilloscope to display the input signal as well, okay? Okay, so this is the probe for the function generator, okay, positive, negative. The function generator has been set to be sine wave, so I'm going to give it here and here, the input side, okay. And then because I want to display the input as well, use another jumper for the oscilloscope, okay. Right, so oscilloscope has two channels, okay. So there are, you can see here, there are two channels that I can use, and you must make sure that this is at 1x, okay, so that you can see a one-to-one output. And similarly, look at the other probe as well. I'm going to clip this here. The clip, this guy, okay, must be at the input, and then the ground, the output, okay. Okay, so this is the construction of the circuit, right? So I'm going to show you the output at the oscilloscope, okay. Okay, so this is the function generator, okay, the one that gives the sine wave, So you can see the sine wave here, okay, at the top there, right? So in order to change the frequency or the amplitude, you just need to press the function here. And for example, now the frequency is blinking. So I want to change it to 1 kilohertz. I press 1 and kilohertz. You can see the kilohertz there. Right. Now I want to change the amplitude. I must press amplitude. So now you see the amplitude is blinking. Okay. So I want to change it to 2 volt peak to peak. Means that 1 volt amplitude. I will press 2 VPP. Okay. So you can see VPP over there. Okay. So that's the function generator. So now this is the output of the oscilloscope. Normally when you want to view the output, you press the auto set, okay, just to refresh the oscilloscope. I'm going to press it, okay, so it will generate like that. Okay, so you can see here, the scale for channel 1 and channel 2 is not the same. So we need to make it the same, okay. In order to do that, you can see that there is this volt per division knob. So let's say I want to change channel 1, so I will use this volt per division on top of channel 1 there, and similarly I can change channel 2. You can see there the measurement, and you can see the channel 1 which I use for my input signal. The V peak to peak is 2 volt, which I have set at the function generator just now. Okay, so I'm going to change the volt per division. Okay, so now you can see the volt per division is now the same, but then it's not the same axis. So what can you do for that is you can use the position knob. So you can bring the signal from your channel 1 to the axis and channel 2 as well. So I'm going to do that now. Okay, so I'm bringing my channel 1 down. Okay, so you can look at that highlighted black statement there. I'm going to move it until it goes to 0 volt. Okay, there. So now I'm going to move my channel 2. I'm going to bring it up. So this is your half wave rectifier. So you can see the peak value is lower because the output of half wave is V out equivalent to Vs, the secondary input of your transformer, Vs minus V gamma. So that's why it's lower. You have successfully managed to rectify it, kan? Okay, so and in addition you can see that the half wave started later because it has to wait until Vs reaches V gamma before it can turn on the diode. Okay, so that's half wave rectifier.